I wanted to take a moment to sort of compare and contrast the graphs of exponential and logarithmic functions. So we talked a little bit before about the inverse and how the inverse would reflect it over the line y equals x. So as you can see, if I have a very basic exponential function, I have a very basic logarithmic function, that these two are in fact inverses of one another. The first one, the exponential function, has a domain of negative infinity to positive infinity. Notice that the range of my logarithmic function matches with that. The range of my first function is from 0 to infinity, so that's the y values from 0 on up. The domain of my other function mirrors that. So here, notice we didn't have anything on the left side of the y-axis. The exponential function has a horizontal asymptote at y equals 0, so that's here it's approaching 0 as you move to negative infinity. A vertical asymptote on the logarithmic function means that, notice here, it's getting closer and closer to the y-axis. The exponential passes through 0, 1, and the logarithmic passes through 1, 0, which of course makes sense because they're inverses. Now we already know how to find inverses, but just so we understand, if I wanted to find the inverse of y equals b to the x, I would say x equals b to the y. And then in order, and we haven't learned this yet, but in order to then turn it into a y equals equation, I would have to take the log base b of x and the log base b of b to the y. So using some properties that we haven't yet covered, which we will in just a few moments, log base b of x on the left side, on this side the log base b of b, we have talked about that one, gives me just y. So it's y equals log base b of x. So that's how we get from one to the other, and that's how we know that they're inverses. So without actually graphing this, I want to sort of talk a little bit about the difference between the parent function and the transformed function. So again, if my parent function is y equals 2 to the x, that's this function here. Notice it's going through the point 0, 1, because my scale is 2. Now, if I'm going to use transformations to graph the function, I need to pay attention to what's happening here. So it's clear, based on this, that my h value is actually -1, because I would have subtracted -1 for it to be +1. Since h is less than 0, it's shifting to the left. So it's basically taking this and it's shifting to the left 1. The negative, because it's a negative value, is actually going to flip it, and so the a is less than 0, reflects it across the x-axis. So this point that would be here is now here. And the other 1 is kind of like a +1 at the end, which is, of course, because it's greater than 0, is shifting it upward. And so instead of being right here, it's shifted upward to 1. Same thing's going to happen with our logarithmic function. Again, this just gives you all of the different ways that those can be transformed, just like we talked about with our polynomial functions as well. In this question, we can see that our function has already been graphed, and it is a logarithmic function. We're asked to find the domain, the range, and the vertical asymptote for this function. So typically in a logarithmic function, my domain would be 0 to infinity, and my range would be -infinity to infinity. What's going to change based on the fact that I have an x plus 3, however? I know that whatever I'm taking the log of needs to be greater than 0. So I'm going to set x plus 3 to be greater than 0, which means if I subtract 3, x is greater than -3. So my normal domain of 0 to -infinity is now a domain of -3 to infinity. Because notice I've got some values that are, below on the negative side. The range is not going to be affected by that, -infinity to +infinity. The vertical asymptote, that's the asymptote up and down, would be, of course, the line that would be right here, which would be that x equals 3. In this question, we're asked to find the domain and range in interval notation and then determine the asymptote. I know in a normal exponential function, my domain is negative infinity to positive infinity, and it's very clear based on this graph that that has not changed, negative infinity to positive infinity. I can plug in any value that I want. The range is generally 0 to infinity, and I can see based on the graph that that hasn't changed either. This -2 did not shift my graph up or down, so it would not affect the range. This -2 would have shifted my graph to the right 2 places. The horizontal asymptote, horizontal of course being this one, would be the line y equals 0, again because we did not shift it up or down.